like find the highest power of 21 in 100 factorial. So the previous one, what you have seen is, we have seen that 2 in 50 factorial, 2 is a prime number. So we are looking only for the prime numbers here. So in the factorial problem, the main thing which you have to understand is, we are only going to see the numbers in terms of prime number, not the composite number. So when you see here, 21 is a composite number, not like 2 which you have seen in the earlier case. So composite number, again, you split that and write in the form of a prime number. So when you write this 21, this is nothing but 3 into 7. So when you have 3 into 7, what you have to do is find the number of 3's in 100 factorial, or find the number of 7's in the 100 factorial. Combination of those two is going to give you the number of 21's. Okay, so when you do this, you can just find out, like, number of 3's in 100 factorial is 48 and number of 7 is 16, and this is a standard value. The combination of 2 is possible only 16. Like, you can't have more than that, because even if you want to take 3's extra, there are no more 7's available more than 16. So there are only 16 combinations are possible. So basically, this is another clue which you should have. Whenever you are considering this, whichever is lower should be your answer. Okay, the wrong approach is, if you are trying to take this 21 and divide it, that's the wrong way. You cannot divide this successive division method which you are applying here to find this number of 3's or 7's. You can't do the same thing for the composite number. So it has to be done only in this way. Find the highest power of 2 power 3 in 51 factorial. So far, whatever you have seen is like number of 2's in 50 factorial, you have seen that. And then number of 21's also you have seen in the previous question is 100 factorial. And there, like, this was taken as 3 into 7, and finally you found out number of 3's or number of 7's, and then combination of that you have seen. Now this is a new problem where you have to find out the number of 8's. Number of 8, that is 2 power 3 is nothing but 8. So number of 8's you are going to see in 51 factorial. So here the small difference is there, that is nothing but 8 is not a composite number, 8 is not a prime number, but when you take it in the form of a prime number, this is nothing but 2 power 3. So the power is involved. So far what I have seen, there was no power in 2's, there was no power in, other than 1. No higher power was involved. Even in 21, there was no higher power involved. Whereas when you go for 8, you are getting the power as 3. So what to do for this? It is the same conditions, like you find the number of 2's in 51 factorial. Okay, so that is again, you know the method how to find that. Like, you're adding up all this, I'm going to get 47. So already you have seen for 50 factorial it was 47. So 51 factorial is going to be 47, because in 51 you don't have 2's. So 50 factorial or 51 factorial, you're going to get the same 47. And then you write, that is number of 2's, it is 47. Okay, and you need 2 power 3. So whatever the power you have here, that you have to divide this by. That's it. So, and take the quotient. So the quotient what you get here is 15. So this is what is your answer. Because a combination of 3 2's will be giving you 8. So we have to divide this by 3 and get this. So whenever the power is involved, this is the method. Like here you have a single prime number. So even for this also, I'm just writing this. Write the number of 2's here. Then take this power, bring it here, divide it. And whatever the quotient you are getting, that is going to be your answer. This is only quotient, not the remainder or the full number. Okay, so the 15 is going to be the answer.